In section 3.1.2, I'm going to show you a couple of tricks to factor polynomial and find its roots. All right, so we need to do this when we want to find eigenvalues. We need to factor the characteristic polynomial and find all of its roots. So here are two theorems that could help you factor the characteristic polynomial of a matrix A or any polynomial, of course. All right, first, rational root theorem. Let P of x be a polynomial with a rational root R equals A and B, where A and B are integers with no common factors, so simplified fractions. So if P of x has these coefficients here, then A divides A0 and B, the denominator, divides AN. If you have a 1 here, then A divides A0, but then AN is 1, and so the only thing that would divide it is plus or minus 1. So really, in this case, your roots are integers divisor of A0. All right, remainder theorem. Let P of x be a polynomial and let C be any real number. The remainder of the division of P of x by x minus C is P of C. And so x minus C divides P of x if and only if P of C is 0. So the factors correspond, the linear factors of a polynomial corresponds to its roots. All right, so let's try this. All right, I want to factor this cubic. The only tool we have for cubics is factor by grouping, and in this case, it doesn't work. Yeah, it doesn't work. And so here's how I would do it. I would try to use the rational root theorem to find roots, right? So step 1, find roots, zeros of P of x using the rational root theorem. Okay, so it's a monomial polynomial. The first coefficient is 1, so we're in that case. So we're looking for a root A over B, which is really A over plus or minus 1, which is plus or minus A, where A divides A0, and in our case, A0 is 2. So really, we don't have that many possibilities. The only divisors of 2 are, well, plus or minus 1, plus or minus 2. And so R, well, we have tons of plus or minuses, but really we end up with 4 possibilities. All right, let's try them. P of minus 1. That's minus 1 cubed plus minus 1 squared minus 4 times minus 1 plus 2. That gives me minus 1 plus 1, 0, plus 4, that gives me 6. It isn't 0, so that's not a root. If I try P of 1, I get 1 cubed plus 1 squared minus 4 plus 2. I do get 0. And so as soon as I find a 0, I move on to step 2. Divide P of x by x minus your root. Right? So in this case, the fact that P of 1 is 0 tells me that this polynomial is divisible by x minus 1. All right, so I'm going to do it the English way. If you learned it the French way, kind of stop the video and do it your own way. This is not going to help you, and there's no need to change. They're both fine. Sorry. I said the French way and I started the French way. All right, so this is what I'm trying to divide. I'm going to divide it by x minus 1. So x fits inside x cubed, x squared times. So I get x cubed minus x squared. That leaves me with 2x squared minus 4x plus 2. I'm going to fit x minus 1 2x times more, so I get 2x squared minus 2x. I'm going to get minus 2x plus 2 left. I get a minus 2 minus 2x plus 2. I get a 0. So as predicted, it actually divides, and the remainder is 0. And so what we found is p of x equals x minus 1, x squared plus 2x minus 2. And now to find whether this splits or not, I'm going to use the roots again, but now it's easier because I have quadratic formula. So minus 2 plus or minus square root of b squared minus 4ac plus 8 divided by 2a divided by 2. I actually get 1 plus or minus, I divide the interior by 4, I get 3. All right, so we have our polynomial completely factored. So p of x is x minus 1, and then I take x minus the first root, x minus the second root. I have a factored polynomial. All right, so if you're stumped when trying to find eigenvalues, this is something you can use.